Hey everyone, Mr. Skelton here. We are back at it for lesson 4 in unit 1, and today we are going to be focusing on linear functions. You got 3 learning targets today. As you can see here at the top, I can write and graph linear functions given a situation. So we're going to start with situations. The second one is I can write and graph linear functions given 2 points. 2 points meaning x comma y and x comma y. And then I can write and graph linear inequalities. Inequalities, remember, inequalities greater than, less than or equal to, greater than or equal to, and their applications. So that's what are going to be our focus for today. Let's jump right into it. So on the first slide here, you can see I have listed for you 2 different linear functions given a situation. Now, before we get into these, let's remember or recall linear functions. Linear stands for basically line, something that is a straight line. And what do you remember from your Algebra 1 days of the equation for a line? Hopefully you're recalling y equals mx plus b, where m represents the slope, or what we call the rate of change, right? And then b is our y-intercept, okay? And when we're talking about situations, your b is really your starting value. Okay, and you'll see that come into play, and I'll make note of that as we get going here. So y equals mx plus b, you should remember that from your Algebra 1 days. Let's apply it to some of these questions. Number 1, write a linear equation. So anytime it asks you to write a linear equation, I'm asking for y equals mx plus b. That's what I'm asking for. For Allie's profit after selling X number of hats. Here's the situation. After buying all of her supplies for $135, there shouldn't be a comma there. Okay. $135. Allie began selling her stocking hats for $12 a piece. So we want to write a linear equation that represents that. Anytime you see a rate, $12 a piece, $6 per hat, $7 per gallon, that is a rate that's going to be representing your slope. All right. So how much profit? So I'm going to go P equals, we're trying to find profit, $12 per hat. Now, after buying all of her supplies, a lot of you are going to want to put plus 135. That would mean you started with $135 in your pocket, but you didn't. You went out and paid, or Allie went out and paid and bought, so she's down $135, okay? She has spent that much of her own money to buy all the supplies, and now she's going to be starting to recoup that money when she's selling her hats for $12 a hat. So there is our linear function. Okay, how much profit would she have after selling 25 hats? We're going to plug 25 in for H, and hopefully if we calculate this, we should get 165. You can take out your trusty calculator, right? 12 times 25, hit equals. Subtract that from the money she already spent, and she's made $165. Okay, that's situation number 1. Situation number 2, I would like you to try on your own. So go ahead and hit pause. Try it. It's very similar to this one with Allie and her hats. See what you come up with. See if you can get 57,600 gallons. Okay? All right, we're back. So here's the situation. When the pool is full, it holds 192,000 gallons of water. When they empty, keyword, when they empty the pool, they can take out 2,800 gallons every hour. There's your rate. There's your slope. So basically, how much water is left after 48 hours? So water equals, that's what we want to have left. We're taking out or subtracting or losing 2,800 gallons of water. So I'm going to call that G. We're losing that amount, so it has to be deducted, it has to be a negative. We started with 192,000, so plus. So we started with this much in the pool in a positive gallons. We're losing 2,800 gallons per hour. After 48 hours, we would just plug 48 in. After 48 hours, and we should be getting 57,600. Okay? You can do the math, the calculations there on your own. I should have put, this should be an H probably, not a G. Make that an H. 2,800 gallons per hour. There's your rate. Okay, let's move on. So this is focusing on the second learning target, which is coming up with linear functions. Again, our final answer is y equals mx plus b is what we're going for here. Given 2 points. So given 2 points, and let's see if we can extract out from problem number 3 the 2 points that we'll be using here. So Timmy's got a lawn mowing business, and it's been profitable this summer. After mowing 18 lawns, Tim profited a total of $20. But after mowing 30 lawns, his profit was up to $395. That seems kind of odd. Why would there be such a difference in the amount of money? Well, one of the reasons could be he had some expenditures at the beginning. Maybe he had to buy new equipment. Maybe he had to buy gas and a weed whacker and maybe a new riding lawnmower. And so he didn't make that much money after the first 18 lawns because he was recouping some of his money that he spent for supplies. Very similar to question number 1. Now, we need to come up with the 2 points. Just like if you were to go on the XY coordinate plane and we were to call this lawns, and maybe this was the profit or dollars amount. So something X, something Y is my point. So we could go 18 lawns, comma, $20. That would be 1 point. And then the second point would have to be following the same order. So 33 lawns, 18 first, lawns, 33 first, and then $395. Okay? Now from here, what you can do is we need to find, if we're going to go y equals mx plus b, oops, sorry, I was off the page there. If we can go y equals mx plus b, what do we need? We need a slope. So if you remember from your Algebra 1 days, slope is the change in y, the differences in the y's over the change in x. In other words, y2 minus y1 over x2 minus x1. So that would be 395 minus 20. Those are my y values. Over 33 minus 18. And if you do that math, you get 25. So what does that mean? What did we just figure out? 25 over 1, right? Essentially, when we reduce this. So what was on top? Well, my profits were on top. So this is $25 because that was $395 minus $20, so that's dollars on top, and lawns on the bottom. And I know we don't usually put 25 over 1, but to understand what the slope is representing, I think it's important to understand. So this is $25 per lawn, okay? That's what the slope represents. So $25 per lawn is his rate. Now, it says write a linear equation. We have the slope. Now we need to figure out the y-intercept. I like to just use y equals mx plus b, and I know I'm running out of a little bit of space here. I just use y equals mx plus b. You'll notice I have 3 variables here. I need to find out what the y-intercept is. I can choose one of these 2 points here and plug it in for x and y. So I like to use the smaller numbers. So I'm going to go 20 equals 25 times 18 plus b. Now, if you solve this, 25 times 18 gives me 450. All right, and if I take the 450 and subtract it to the other side to solve for b, I get b equaling negative 430. So after all this work, my equation for this situation is y equals 25x minus 430. Okay, that is my linear equation. What does that represent? Well, this represents Tim's making $25 per lawn. He started out with negative $430 in the hole. So maybe he bought a weed whacker or a lot of gas or a new lawnmower or whatever, but he started out in the hole $430. Using your equation to predict his profit after mowing 50 lawns, all we would do is take our 50 lawns, we would plug them right in there for that X, and we should get $820. Okay? I would like you to push pause and try number 4. Again, you're creating a linear function, possibly given 2 points. This one's slightly different, okay? Slightly different. All right, we're back at it here. So we have a situation where we have Samantha choose 6 pieces of gum per day. Now, as soon as I read that, I have my brain going off because I notice that I'm already given the slope. That's a rate, okay? So we know she averages 6 pieces of gum per day. we know that after 11 days, she still has 384 pieces left. Write a linear equation for the number of pieces of gum she has left after X amount of days. Okay, so the 11 days and 384 pieces represents a point, 11 comma 384. We have a point, or we have a point, we have a slope. Again, I choose to use y equals mx plus b all the time. You're going to see on our very last page of the notes, you can also use point slope form. Some of you may be familiar with point slope, y minus y1 equals the slope x minus x1. That's called point slope form. You can use this, I'll put it down there, point slope. You can use point slope form when you have a point, 11, 384, and a slope, 6. And you can plug those in and get the same answer I'm going to get here. I just like to use y equals mx plus b because it's the same thing, and most students remember that. So 384 is going to go in for my y, because that's the y value of the point, equals my slope we know is 6. My x value is 11. Again, I got that x value from the x coordinate of the point, plus b. So I'm solving for b, or finding my y intercept. So I have basically 384. I'm going to subtract 66 from it, and I get 318 is what I get. Nope, I'm sorry. This should be, bear with me just for a second. Let's see. She chews 6 pieces of gum, so that's got to be a -6 because she started off with so many pieces of gum. She's losing gum, right? She's losing gum. I had to catch myself there. So what I should do, this should be a -66. This is 384. I got to add 66, so I should get 450 for B. She's chewing gum, so she's depleting her stockpile of gum. So that's got to be a negative slope, -6. All right. So my final answer then for my equation is going to be y equals, that's going to be a -6x, because -6 is my slope, and plus 450. Okay. So what does that mean when we translate the equation? That is, she's chewing 6 pieces of gum per day. And the 450 means that's what she started with. She started with 450 pieces of gum. That's a lot of gum. Now this second part says use your equation to predict how many pieces she will have after 31 days. So we take that 31 and plug it in for that x right there, and then solve. You should get 264 pieces of gum. So those first 2 slides are dealing with linear equations. Again, you see some similarities between all 4 equations. Very similar. We're getting to y equals mx plus b in the end, but I think it's real important that you take your time to understand what each part of the equation represents for the situation. I think that's kind of understanding the big picture there. So let's keep on moving here. At the bottom of slide of your second page here, we have 2 equations, and I'm asking you to graph them. Now notice these are inequalities. Remember, inequalities are greater than or less than or greater than symbols, or equal to's, and we're graphing this. Now, we got to recall a couple things here. First of all, my notes, that's a 3. When graphing y equals mx plus b, we always want to graph our y-intercept first. So the y-intercept is where the graph crosses the y-axis. So at plus 4, I'm going to put a dot. So that plus 4 is the plus 4 on the y-axis. Then my slope is -2/3. Now, when the negative's out in front, I always just put the negative on the top of the number. It's the same exact thing. So I can go down 2 and to the right 3, 1, 2, 3. I'll repeat it, down 2, 1, 2, 3. Don't draw a solid line through that. Notice it's an inequality. You may or may not remember that when you have a less than or greater than symbol, that represents a dotted line or a dashed line. If you have less than or equal to, greater than or equal to, that represents a solid line. Okay? The other thing that you cannot forget to do, and a lot of kids forget, is we have to do some shading. Remember, inequalities, the answers are not just falling on the line itself, like an equation, an equal sign. This is an inequality. Y is less than. The way I remember to teach this, and I'll probably show you a couple examples in class, I just kind of cover up the expression y is less than. So I always ask students, put your pencil or pen on the graph, and you're either going to shade up or you're going to shade down. Every single time, you're going to shade up or down. y is less than up or down? Less than is down, so you would shade down or away from the graph or the line. Okay? The other way to do this very quickly is to try a test point, like 0, 0. If you plug 0 in for y, you'd get 0. Negative 2/3 times 0 is 0, and 0 plus 4 is 4. Is 0 less than 4? That is a true statement. You always shade the solutions. This represents your solutions. A lot of students don't realize that. They just shade because they think it looks colorful and neat. But you're shading the solutions. If I pick any point in this shaded region and plug it in for x and y, this inequality would hold true. Okay? What I want you to do on number 6 is hit pause and try this one on your own, see what you come up with. All right, so this is in standard form. And we use standard form for a variety of reasons in algebra. For now, what I'm going to ask you to do, or what I would probably do, is solve for y. Put this in y equals mx plus b form. So I would subtract 4x. I get negative 6y is greater than or equal to negative 4x plus 12. And I'm going to divide everything by negative 6. And when I divide by a negative, what happens to my symbol? It needs to flip. And so I get 2/3 positive, and this becomes a negative 2. So I get something that looks like that. And now I can graph that. So down negative 2, that's my y-intercept. Again, that's my y-intercept. I'm going to go up 2, 1, 2 over 3, 1, 2, 3, up 2 over 3. And because this is or equal to with this line underneath it right there, I'm going to have a solid line. In terms of shading, again, the shortcut is just to cover that up and just read this out loud. Y is less than. Less than means up or down. Means down. So put your pencil on the graph. Less than means less underneath. So I shade down here. Remember, shading represents all your solutions. If you tested 0, 0, watch what would happen. Put 0, 0 into the original. 0 times 4, 0. 0 minus 0. Is 0 bigger than or greater than or equal to 12? It is not. So you can't shade above the line because we just proved that 0, 0 does not work when you plug it back in. So you can use the shortcut, or you can plug in a test point to find your solutions. Okay? On the back, this very last page is just some reminders. There's really no problems to do here. It's just a couple things to kind of review from your Algebra 1 days. The basics of linear equations. There's really 3 equations, and we kind of talked about all 3 of these very briefly. We expanded upon y equals mx plus b, put a couple reminders there for you. Standard form, our very last form was in standard form. So that's the standard form of the equation. A lot of times that's used for the x and y intercepts, although I did not ask you to do that in any of the problems today. And then point slope form. Again, point slope form can be used when you have a point and a slope in the problem to help put your final answer back into y equals mx plus b. So really point slope form has a strong relationship with y equals mx plus b because you usually take this equation and end up putting it back into y equals mx plus b. Okay, I put some tips down there for you. You can read those on your own. And that is it for lesson 4. So as always, if you have questions, I look forward to seeing you in class and getting those questions answered for you. And I hope you have a good rest of the day. See you.